last little piece is going to be dealing with center of mass. And I'm going to approach it this way. If I have a 100-gram weight on one end of this meter stick, and I put the pivot here, can it balance? And it seems like no, because there's a weight causing a torque on this side, but there's no weight on the other side. But it turns out it can, because the meter stick has mass. So the answer is going to be yes, because of the mass of the meter stick. The only question is, where do we put that mass? And it turns out you assume that the mass of the meter stick is all at the center of mass of the meter stick. And in AP Physics B, the center of mass is always just going to be at the middle. In AP Physics C, you might deal with things that aren't uniform like this. Maybe they're heavier at one end than the other. But a meter stick is pretty uniform. So we would find the middle of the meter stick, and we would put the mass of the meter stick right there. So here's an example problem. All right. So we have a mass out on one end, and then more of the meter stick over to the right. Here's my pivot point. I always want to identify that. And it says the mass of the meter stick is 40 grams. So I'm going to find the middle of this meter stick and place it there. Now each of these lines is 10 centimeters. So halfway through would be at 50 centimeters, would be right here. And I'm going to say that there is a 40 gram mass right there. Now, if I want to find torques, I need to have forces and I need to have distances in meters and in newtons. So this distance right here is 10, 20, 25 centimeters. So I'm going to mark that this distance is 25 centimeters. For centimeters, I move 2 places, so that's 0.25 meters. On this side, from the pivot point to the center of mass, is going to be 20 centimeters, which is 0.20 meters. Now, it's 40 grams. If I want to calculate forces, I have to convert that into kilograms. So kilo means 1,000, so I move 3 places. So this is 0.040 kilograms. Now the force down on this end is equal to 0.040 times 10 is 0.4 newtons. And the force over here is going to be 10 times m. Now I'm ready to do the problem. To find the torque on the left side by doing Fx. I can ignore the sine theta because we got right angles again, and that's going to give me 10m times 0.25, which is 2.5 m. My torque on this side is going to be the force of 0.4 times the distance of 0.2. That's going to give me a value of 0.08. And then I can set those equal. So 2.5m equals 0.08. When I divide that out, I'm going to get m equals, and I get an answer of 0.032 meters. Sorry, kilograms. Kilograms. Now, I want to show you a shortcut. This is the right answer. Okay? There is a shortcut. If you are on the AP exam and there's a multiple choice question like this, you can take a little shortcut. Because you'll notice that for both distances, I move 2 places to the left. For both forces, I multiply the mass by 10. I don't need to do all that. Okay, if I want to make it really quick, let's just kind of draw this out again. Okay, I have my pivot point here. This distance will say, instead of converting it to 0.2, we'll leave it as 20. This distance will make 25. This mass will leave as m. This mass will leave as 40 grams. All right, we'll do the same thing. We're basically multiplying force times distance. I'm not even going to turn them into forces. I'm just going to do mass times 25 equals mass of 40 grams times 20. So now I get 25m equals 800. When I divide it out, I get m equals 32. Now, the thing that's different is, since this 40 is in grams, the mass on this side is in grams, the mass on this side is going to be in grams, so it's 32 grams. And that also is the correct answer, because if I convert kilograms to grams, I move 3 places, because kilo means 1,000. If I move this over 3 places, over here, I end up with 32 grams. So it's the same answer. So this is a little shortcut. Don't bother using forces, just use masses. Don't worry about your units. If they can be in centimeters and they can be in grams, you just have to remember that your answer in the end is going to be in grams.